Hello, this is Dr. K. Welcome to this week's module, Module 4, on Requirements Engineering, which is based on chapters 7 and 8 of Software Engineering, a Practitioner's Approach by Roger Pressman and Bruce Maxim. In this module, we're going to talk about what it takes to gather requirements together for a project, and we're going to discuss why that is just so hard to do. We'll also spend a little time on some software engineering principles that are associated with each of the framework activities. So before we start talking about requirements in depth, we're going to spend a little bit of time on software engineering principles. You can think of this chapter in Pressman as a little taste of what's to come in the subsequent chapters. And since these slides are mostly long lists of principles, I'm not going to go over each principle. I'm just going to hit the highlights. So you might want to either pause the video on each slide and read the principles for yourself, or you can just review the PDF version of the slides after you watch the video. We start with a few principles that pertain to processes in general. A few things that struck me when reading this section of Pressman was that agility is something you should pursue regardless of whether you're using a prescriptive or an agile process. Managing change means having some mechanism for managing the way that changes are requested and implemented. Assess risk includes establishing contingency plans for when something does go wrong. And in general, it's interesting to me how many of these principles echo the agile principles we discussed in the last module. Here are some general principles that Pressman talks about. From my point of view, these look like design principles that developers or programmers should follow. Patterns, modularity, abstractions. One of the most interesting is the last one. Remember that someone is going to be maintaining the software that you create. So when you're designing your system, when you're writing your code, always keep in mind that someone is going to have to understand what you have designed, and someone is going to have to read what you've written. If you can keep that thought in the back of your mind, your system is going to be of much higher quality than it would otherwise be. Here are some communication principles. I think that most of these are probably common sense. The first one here, my guess is that's the most important. Just be a good listener. When you're gathering requirements, this is going to take you the furthest. Most of us love to hear ourselves talk, but if you're a good listener, you're going to be a good requirements gatherer. A few other highlights. Pressman's really big on having a facilitator in requirements gathering meetings. And I think one of the reasons for that is related to one of the last principles here about moving on. It can be very easy to get sidetracked or to get stuck in one particular topic when it comes to discussions about requirements. A good facilitator knows how to prevent that. Here's how Pressman puts it. Once you agree on something, move on. If you can't agree on something, move on. If a feature or function is unclear and cannot be clarified at the moment, well, move on. So with that, let's move on. A big part of planning is understanding the scope of the problem. Some of these things are obvious, like involving the customer and defining how you're going to ensure quality or accommodate change. Estimate based on what you know means that you estimate based on what you know you're going to build, not what you might decide to build in the future. Being realistic means don't assume that your team is going to work 100% of every day. And adjusting granularity just means that as a project plan is developed, you can become more detailed about what's involved in that plan. Pressman gives some agile modeling principles here. Overall, it's worth noting that the principles of agile development don't really talk about modeling that much in general. In fact, most agile developers would probably agree strongly with the first principle here. The primary goal is software, not models. Agile development often seems to de-emphasize the modeling activity in favor of the development activity. This is something that seems to concern Pressman. And it's almost as if he wants to say here that you can be agile and still create analysis models and design models. General requirements analysis principles focus on three things that Pressman says are essential to the analysis model, namely information, functions, and behavior. Information is the data involved in your system. Functions are the operations that manipulate that data. And behavior is how the system responds to external events, like a person interacting with a system or a device sending information to the system. These design principles include some interesting notions. Traceability is the idea that portions of the design, and therefore specific lines of code, can be traced back to specific requirements. Now, if this were easy to do, changing requirements might not be that big of a deal. If you know what portions of your code exist due to a particular requirement, then presumably you should only have to modify that code if the requirements change. In practice, traceability is a hard problem, even with tools to help you achieve some level of traceability. We'll talk a lot about interfaces when we get to component design. Likewise with cohesion and coupling. Understandability is of course important, and that last item is again Pressman insisting that you don't have to skimp on design if you're doing agile development. Okay, coding principles. This is the fun stuff. Structured programming just means you break your code into modules and functions and use loops and if statements. Almost everyone uses structured programming today, so this probably isn't something most people need to worry about. We talked about pair programming when we discussed the extreme programming process model. Data structures are structures that hold data, like arrays, lists, maps, sets, and databases. Again, Pressman emphasizes interfaces and architecture. Conditional logic means if statements and case statements. Code in general should be testable, but some types of code, like nested loops, are more challenging than others. Variables should be named appropriately, and in general, if you name variables and functions well and structure your code well, including the visual layout, then your code becomes more readable, which is one of the most important qualities of code, because it's going to be read by other developers. We'll spend a module later in the course talking about testing strategy. Some of the principles here won't make much sense until we reach that module, and other principles are more common sense. One interesting principle here is the Pareto principle, which says that it's common for 20% of the code to have 80% of the bugs. Finally, deployment principles. Most of these are self-explanatory, and all of them seem to relate to what you do before you deliver the software. Okay, that concludes our quick look at Pressman's principles. In the next video, we'll begin talking about requirements and requirements gathering.